All right, everybody, welcome back. We are now on lesson number 3. Hopefully the long division made sense. If it didn't, you actually don't need to know how to do long division for Math 12. If you're going on in math, you will need to know it, but you can use synthetic division, what we're going to learn today. So we are on page 303. And here's an example of long division here. Dividing 3x cubed minus 7x minus 9 by x minus 2. So the x minus 2, the divisor goes on the outside. Inside goes the polynomial, but we have to add in the placeholder, the 0x squared, because it's x cubed, x, and 9. We followed the rules all the way down. We get our divisor up here and our remainder down here. And then we rewrite it as dq plus r. Okay, that's quite a bit of work. Here's the same question done with synthetic division. Okay, very short, a little simpler to deal with. That's what we're going to learn today. It is faster, and you can always use synthetic division when your denominator, or what you're dividing by, is linear. And linear means degree of 1. Synthetic is much faster to use. If it's a nonlinear, which we do not deal with in Math 12, it gets much more complicated to use synthetic, and actually long division is a faster and better way. But for Math 12, we will only deal with linear denominators, so synthetic division is all you need to know. Okay, we're going to skip to the next page. How to fix this? All right, so we're dividing 2x cubed minus 3x squared minus 8x plus 15 by x minus 1. Here it is set up. This is our divisor, so the number goes on the outside. Basically, this number here is what makes this term equal 0. And in this case, you can see it is 1. Okay, so we put the 1 on the outside. The numbers inside, and it's not a regular division sign, it's this little bracket here, are just the coefficients. 2, negative 3, negative 8, 15. 2, negative 3, negative 8, 15. You always take the sign that is in front of the terms. Okay? All right, so now we do this. All we do, first term, just bring it down. You don't do anything. Then you multiply. So we go 1 times 2 is 2, and that's what goes in that bracket, or that right below the next number. Again, synthetic division, you're always adding. Negative 3 plus 2 is negative 1. Then you multiply by this one. 1 times negative 1 is negative 1, and that goes in the next line. Adding, always adding. Negative 8 plus negative 1 is negative 9. 1 times negative 9, 15 goes there. Add 15 and negative 9 to get 6. The last term is your remainder. These are the coefficients of your quotient, okay? So we divided a cubic by degree 1, so we should get a quadratic, i.e. we drop the degree by 1. So this is actually 2x squared minus, and I'll put the terms in, 1x minus 9. That is our quotient. And then we never are going to write it like that. We're going to write it as dq plus r. So we go divisor, which was x minus 1, quotient, over here, plus the remainder, which is 6. And that is it. All right, let's do another one. Now, we're going to divide 5x to the 5th minus 6x to the 4th plus 3x squared minus 2x plus 1 by x plus 2. Now, if you're going to do that with long division, it's going to take you about a page. But with synthetic, you can do it in a small space. So this is our divisor. What makes it 0? -2. So on the outside here, I put -2. And then I put in all the coefficients. Again, if you are missing any, we don't go down in proper order. You'd have to add in a 0, but in this case we don't. It's 5, 4, 3. Oh, we do miss one. There we go. So there's no 3, so, or x cubed. So we write 5, -6. Now there should be an x cubed there. There isn't. So you put a 0. 3, -2, and 1. Okay, now we do our synthetic division. 5 falls down. -2 times 5, -10. Add -6 and -10, -16. -2 times -16 is 32. 0 plus 32 is obviously 32. -2 times 32 is -64. Add -64 and 3, you get -61. -2 times -61 is 122. Add those together, you get 120. Then I get -240. So last term is your remainder. These are the coefficients of your quotient. And it was a 5th degree polynomial divided by a degree 1, so it should be 5x to the 4 minus 16x cubed plus 32x squared minus 61x plus 120. And that's it. That is your quotient. Quotient. All right. They didn't ask us to rewrite it, so that's okay. All right. Find the value of the polynomial when x is replaced by -2. Okay, so basically what they're saying is put -2 in for all your x's. So if I go 5, -2 to the 5th, minus 6, -2 to the 4th, plus 3, -2 squared. Remember, -2 needs to go in brackets every time. -2 is -2. -2 to the 5th is -32. -2 to the 4th is +16. -2 squared is 4. -2 times -2 is positive. You multiply these out, add them together, you will get -239. Where have you seen that before? Well, you've seen it. Whoops. Right there. It is the remainder. So we're going to call this value the a value, which is what makes divisor 0. Makes equals 0. We're going to call that the a value. So when a is plugged into the polynomial, you get the remainder. This will become important in lesson 4, 5, and moving forward. But for right now, just remember that. When your a value is plugged into the polynomial, you get remainder. If you want to write that mathematically, the p of a is plugged into all your x's, will give you a remainder. All right, at this point, I would like you to do question number 2 and number 5. And when you do that, we have one last thing, and then we are done. All right, everybody, back here on page 305. One other type. Now, if you're doing long division, you're dividing by a linear denominator, but something that looks like this, 2x minus 1, not just x plus 1. It's pretty straightforward, it works out. However, if you are doing synthetic, there's a little trick here. So, what makes this 0? Because this is our divisor. Well, if you set it equal to 0 and solve it, you get 2x is equal to 1, so x is equal to a half. That is your a value. So you can put a half out front. All right, this is set up for synthetic division. That's my a value. Here's the coefficients: 2, 1, 5, negative 1. 2, 1, 5, negative 1. Okay, and then you do exactly the same thing. The fact that it's a fraction doesn't matter. Bring the 2 down. A half times 2 is 1. 1 plus 1 is 2. A half times 2 is 1. 5 and 1 is 6. Half of 6 is 3. Negative 3 or negative 1 and 3 is 2. That is my remainder. My quotient is this. Remember, it was a cubic divided by a linear, so this would be 2x squared plus 2x plus 6. That is my quotient. And here it is. If you write it as dq plus r, this is what you get. Now, people don't like fractions, so what you do is you look at your quotient here. You have a 2, a 2, and a 6. You can factor out a 2 from that, okay, to get x squared plus x plus 3. That 2 then gets multiplied into both of those. 2 times x is 2x, 2 times a half is 1. And you're left with that. There's your divisor, there's your quotient, and there's your remainder. Okay? So that's the only little wrinkle with something that has a fraction in it. All right, we're going to do one more example of that, and then you'll be on your own. So, bottom question here. We're dividing 6x cubed minus 8x squared minus 5x plus 5 by 3x plus 2. Okay, this is your divisor. What makes it equal to 0? If you don't see it right away, simply set it equal to 0. The 2 over. So you get x is equal to negative 2/3. That is your a value. Okay, so if we're doing synthetic, we go, all right. Negative 2/3 goes on the outside. Do I have to add in any placeholders, 0 values? We go 3, 2, 1, 0. So we're fine. So I just put in the coefficients: 6, negative 8, negative 5, 5. 6 drops down. Negative 2/3 times 6. If you're not familiar with multiplying fractions, do it over to the side here. Negative 2/3 times 6. Well, that's like 6 over 1. And you multiply top times top and bottom times bottom. So negative 12 over 3, which is negative 4. Okay. So this is negative 4 goes there. Okay. Add again, negative 8, negative 4, negative 12. I'm not going to do this for everyone, so negative 2/3 times 12 is Negative 12 is 8. You can check my work if you want. Add negative 5 and 3, or 8, and you get positive 3. Negative 2/3 times 3 is negative 2. Add again, and you're going to get 3. Last number is your remainder. We started with a cubic there. So we're going to get a quadratic. So this is 6x squared minus 12x plus 3, my quotient. So then I go, okay, E is dq plus r divisor. So when we rewrite our divisor, you write it with the a value. I don't think I made it clear up here. So if you look back up here, this was our a value, 1/2. When we rewrote our divisor, it's always x minus a, okay? And then when you factor out, it becomes back to what it originally was. So our divisor is x minus a, so it's x minus negative 2/3, so it's x plus 2/3. Quotient is this. Minus 12x plus 3. The remainder is 3. Then to clear out this fraction, what can we factor out of this bit here? We can factor a 3 out of it. So it's x plus 3. Take a 3 out of that. We're going to get 2x squared minus 6x plus 1 plus 3. And then this 3 is multiplied into x. So it's 3x plus 2, 2x squared minus 6x plus 1 plus 3. And there you go. And that's your final answer. Sorry, I didn't really make that clear. Is that, well, let me do one more example. I'll do one of the examples I'm going to assign to you. So I'm going to ask you to do 8 and 9. But if we go to those ones, yeah, I'll do number 9. So number 9, here's our divisor. What makes that 0? It's going to be x is equal to negative 3 over 4. That's our a value. Okay. So negative 3 over 4. Pull out the coefficients from the polynomial. 4, 11, minus 14, minus 9. Do the division. So 4 comes down. Negative 3/4 times 4 is negative 3. That is 8. Negative 3/4 times 8 is negative 6. That gives me negative 20. Negative 20 is 15. Negative 9 and 15 is 6. That's my remainder. This is my quotient, and we were at cubic, so it's a 4x squared plus 8x minus 20. My quotient is equal to that. My divisor, d, in this form is always x minus a, so x minus negative 3/4, which becomes x plus 3/4. So when we're going to write our final answer, we go d x plus 3/4 times the quotient plus the remainder. Now, the number that you factor out of your quotient should be the same as the denominator there. And it is in this case. I can take a 4 out from here and get x squared plus 2x minus 5. The 4 then multiplies into here, and I'm left with 4x plus 3 x squared plus 2x minus 5 plus 6. That is my final answer. And this 4x plus 3 should always match what you started with. Okay, so that's the only trick, is when you rewrite it as dq plus r, your d value has to be with an a, with the a value, all right, the fractional form. Okay, that is it. Asked you guys to do 8 and 9, so hopefully you did. And let's make sure we got 9 number 8, and there it is right there. Number 9 is correct. Okay. Good luck, and email me if you have any questions. Thank you.